Let's discuss what we'll be going through in this tutorial. We'll create a Java Spring app, we'll connect it to the Postgres database, we'll secure it, we'll add social logins to it, we'll track changes to our source code with Git and host our project on GitHub, and finally we'll deploy our app to the cloud. Sounds interesting? Let's begin. This will be a multi-part tutorial, and in this part we'll create a simple Spring MVC app and try to deploy to one of the cloud providers that enable simple deployments on Spring apps, and it also has a very user-friendly interface. It's called Railway.app. There are a couple of things you want to have installed if you want to follow along with this tutorial. Firstly, we'll be using Java version 17 minimum because it's the new baseline for the new Spring Framework 6. Secondly, we'll spin up local instances of the Postgres database using Docker, so you want to have a Docker installed. Thirdly, we'll be using Git as our version control system, so you want Git installed, and we'll host our Git projects on our GitHub, so it's a good idea to open an account there. We'll start by creating GitHub repository, since GitHub as a host for Git projects is tightly integrated with majority of cloud providers that will enable us to deploy our Spring apps. Once we created the new project, we'll clone it in our local environment and we'll cd into it. Next, we'll use Spring Initializer at start.spring.io to create skeleton for our Java Spring project. We'll use Java as our language and Maven as our build tool. I've pre-populated the project metadata with the appropriate fields. Next, we'll choose dependencies for our project. We'll start simple, add Spring Web dependency, Timelift as our templating engine, and a Lombok library that will help us reduce our Java boilerplate code. We'll add additional dependencies as we need. We'll click Generate, and we'll unzip the newly created zip file in a folder created by cloning a GitHub repository. Once the project has been opened in our IDE, we'll try to find application class and try to run it to see if everything works okay. Since we've used Lombok, the IDE warns us that we need to enable annotation processing, which we'll do. Seems the application has started. Let's try to hit localhost 8080 to see if everything works okay. And we get an error page, which in this case is a good thing, meaning that the application has started and given us an error because we didn't define anything or for a root page. Let's create a better user experience and greet a user with a welcome page. We'll do that by creating a new controller. Let's call it a home controller. We'll annotate it with add controller annotation to let Spring know it needs to put an instance of it in the context. We'll create a get mapping for now, just call it home. And we'll return an index page. The index page does not exist for now, and we are using Timelift as our templating engine. By default, it looks for its templates in resources template subdirectory. So we need to create an HTML file there named index. We'll rename the title to welcome for now and just create a div with h1 welcome message. That should be enough for us to restart an application and hit localhost 8080 again and be greeted with a more friendlier message. Let's refresh. And we get a welcome message. Although this is very bare bones and simple web application, it should be enough for us to test our proof of concept and deploy to some of the existing cloud providers. So let's do that now. First, we'll stop the application from running in our local development environment. Then we'll try to Maven clean package it just to make sure the build is successful. And it is. Next, we need to commit our local changes to our Git repo and push it to our GitHub hosted Git project. So let's just make sure the changes we made are indeed tracked and noticed. We'll add them and commit them. After that, we'll push changes to our GitHub repository. And we see they are pushed. If we have a look at our GitHub repository, we see our newly made changes were indeed pushed. One of the cloud providers that will let us deploy our code directly from our GitHub repository is Railway at Railway.app. I'll leave a link in the description. And what's great about them is they have a free trial option that will let us get a feel of how the platform works. So let's log in. Since I'll be deploying my code from my GitHub repository, I'll use a GitHub social login to create a new project. And we'll try to find a project from our GitHub repository. Indeed, there it is. And we'll just deploy it. We don't have any variables to set up right now. What we see is the deployment started and the project has begun building. If we look at the settings tab, we'll see that Railway has created automatic deployment based on our GitHub master branch. And anytime we push something to our master branch, a new deployment will be created. Let's appreciate that Railway has basically created a mini continuous delivery pipeline for us. Another thing to note is, since we didn't buy a custom domain, we'll let Railway generate a domain for us. And after the domain has been generated, we'll have an URL we can share with the world. We'll wait for a minute just for our deployment to succeed, which it did, and for our newly created domain to be accessible. If we try to open the URL right now, it says it's still not found. So we'll be patient and return for a couple of minutes later. Let's briefly try to explain what's going on here if you are new to the Spring ecosystem. The core Spring framework is a dependency injection framework. Its core job is to scan our code, construct a dependency tree, and create and provide dependencies for us, which are just instances of the classes. In Spring terminology, they are called beans. Spring Framework and its dependency injection system is the basis for all other projects under the Spring umbrella. One such project is Spring Web, which provides us ability to create web apps. Important project that ties all of this together is Spring Boot. It gives us initial configuration and opinionated view of what we might need to get started when we use certain technology. If we go back to our app and have a look at the POM XML Spring initializer generated for us during the project creation, we'll see we are provided with a host of Spring Boot starter dependencies. If we drill down further into one of these Spring Boot starter dependencies, we'll see this is where the opinionated part kicks in. It will provide auto configuration, logging by default. Since we've drilled down into web dependencies, it will also think we'll need a library to parse JSON objects. In this case, it provided the Jackson library for us. It also provides Spring Boot starter Tomcat, and it provides Tomcat web server. And this gives us ability to run our application standalone. Latest version of Spring recommends annotation-based approach. So if we go to our main application class, we'll see it's annotated with Spring Boot application. This is, if we drill down into it, we'll see this is where the auto configuration part begins and the component scanning begins. So it will scan our projects for other annotations provided by Spring and Spring Framework to see and conclude what we might need and what we might want. If we have a look at our home controller class, we'll see it's annotated with add_controller. If we drill down to it, we'll see that it's actually just an alias for component class. If we have a look at the class hierarchy and subtypes of the component class, we'll see this is the basis of the core Spring Framework. By using one of these annotations, Spring Framework, core Spring Framework, decides and concludes which are the dependencies of your project and which instances of which class some other class might need. So you might be wondering if controller is just an alias for a component class. Would our home controller work if we annotate it with add_component instead? Well, let's try it out. After we restart our app and hit localhost 8080, we'll see it still works. So if controller is just an alias for component, why don't we use component instead? Well, it turns out that by using specific annotation, you tell Spring Framework and other developers what's your intention with the class. And not only that, Spring includes a test framework and it gives it ability to use specific test slices for only specific types of components. Speaking of tests, let's get back to the POM XML generated for us. We'll see Spring Boot Starter web dependencies included Timeleaf, Lombok, but also Spring Boot Starter test, even though we didn't request one. And it's an important point about Spring Boot and Spring projects. They assume you will be testing and they include pretty much everything, every dependency you need to start testing your projects. JUnit, Mockito, Assert4j, etc. Let's have a look at the default test included in our project. It seems like a dummy test without any body, but it's annotated with Spring Boot test annotation. And it's responsible for trying to create an application context and wire all the dependencies up. And it pretty much guarantees that if this test passes, our application startup correctly. One important point about Spring Boot test annotation is you generally don't want to include it in your own test classes because it tries to boot up the whole application context. That's not usually what you want to do. You usually want to test just a certain part of your application. And let's just drill into it. We'll also see that it's annotated with extend with Spring extension class. This is the way Spring test integrates it into JUnit testing model. You usually don't have to worry about this annotation because it's included in every Spring test annotation. Let's try to write test for our own home controller class. First, we'll annotate a class with web_mvc test annotation. And next, we would auto-wire a mock MVC provided by Spring Framework. What that web_mvc annotation does, it's a slice annotation. That's something we've talked about. It doesn't pull up the whole application context, but just our components that are annotated with controller, controller advice, etc. And it doesn't start a real servlet container, but only mocks one. That's why we auto-wire mock MVC, so we can interact with the mocked MVC container. So let's create our own test now. Let's call it should display homepage. We need to annotate it with JUpiter test annotation. In here we'll interact with mock MVC provided for us. It has a Fluent API consisting of two parts. In first part, we need to tell mock MVC how do we want our request to look like. So we want to perform get on the home page, and in the second part we need to tell it what do we expect, and we expect to get a status of OK. Now it needs to handle exception, and what we can also do is static import those mock MVC matchers, and what we get is something that looks really fluent and easy to read. So let's run our test. And it passes as we expected. Let's get back to the Railway and try to open our app URL. And we get a welcome page. Our app is live. Nice. We'll add security features next, so let's just commit what we have and push it to our GitHub repo. This should start a new deployment, and it does. Since we'll be working on security features next, we would like to test it before we push it directly into production. So one option that Railway gives us is creating a new environment, and we'll do that next. We'll call new the environment develop. And what's the purpose of the new environment? It will give us completely separate URL to access our application, as well as the possibility to deploy and build from some other branch from a GitHub repository. That's ideal to test new changes and only then push them to our master branch. We can change the active environment by selecting it in the Railway list of values. And if we then go to our deployments and settings, etc., we'll see that develop is active environment. For now, it's the same as our production environment because it triggers on changes from master branch, but we'll change this shortly. Let's create a new branch, also call it develop, in our local repo and switch to it. Now, it's currently the same as our master branch. Let's make some minor changes to it just for the sake of it. If we get back to our application and try to start it, we'll see that by default we get Spring banner, default Spring banner. Let's try to change that. We can change that by selecting banner text generator. Let's input the name of our application. That will do for now. We'll copy this text into resources folder of our application, create a new file, call it banner.txt, copy the text, and let's try to restart our application. And we see the new banner is taking effect instead of the old default Spring banner. That's enough of the change for our develop branch. Let's commit it, let's add it, commit it. And let's push it to our remote GitHub repo. It's a new branch, so we will push upstream. Let's get back to our Railway app, and here we see we have a new develop branch available for us now. Railway has detected the presence of a new branch. So instead of the old master branch, what we'll do is pick her as a branch that will trigger our deployments. Now, If we have a look at the deployments, it should be starting right now. And actually we see that the custom GitHub, custom Git message is displayed. So that's the good sign. The good branch is being triggered. And what we also expect in the logs, after the deployment has been finished, the presence of the new banner. This will signify that the correct branch is being picked up. And through the magic of editing, we do have running application. If we do view logs, we see our new banner present. Success. This will conclude our session for now, and in the next video we'll start using Spring Security Framework and adding security features. So bye bye until then, and happy coding.